Hello, my friends, and welcome to the second lecture in our awesome journey under the title How Test Automation is Applied Across Different SDLCs. Now, I know you are all rock stars who are already familiar with the term SDLC, and I know that you can easily anticipate that test automation can be applied differently depending on the context of the SDLC. So rather than crawling through every detail at the beginning, let's jump straight to the conclusion, as it delivers a clear roadmap before we dive deeper into details. And don't worry, it's not rocket science. This stuff is pretty straightforward once you see the big picture. Here's the deal with the waterfall model. Automation in this setup is a bit of a late bloomer. This is because testing usually happens only after the software is fully built, and most of the automation here focuses on system level testing, like checking if the whole app works as intended. Now, let's move on to the V model, where automation is planned much earlier, right when the requirements are being defined, and it follows a clear hierarchy, starting with unit testing, moving up to integration testing, and finally reaching system level testing. And finally, let's talk about Agile, the cool kid among SDLCs, of course. So, in Agile, test automation is baked into the process from day one. It happens continuously at all levels and, most importantly, during the sprint. So, as developers write their code, testers are right there automating the test for these features. So, by the end of the sprint, everything is ready to roll, making it very efficient. Excellent. With that solid and quick ground laid, we are ready to dive deeper into the juicy details in the next slides. So, stay with me, it only gets better from here. All right. Let's take a closer look at the waterfall model. I'm pretty sure you all remember what it looks like, and indeed, it's something minimalistic, a literal waterfall with each phase flowing into the next. But there is a catch. In the waterfall model, every phase has its own deliverables. So the requirements phase has the all famous SRS as its deliverable. The design phase outputs the system design document, and in the implementation phase, we finally get something tangible, the code, of course. Now, the deliverables of each activity must be approved by stakeholders before we can even dream of moving to the next activity. This is why we get a runnable work product very late in this specific model. Sadly, this gives us, software testers, a very limited time to prepare our automation scripts before the verification phase, because without a runnable work product, automation is out of luck. And as a result, test automation usually starts in parallel and sometimes even after the code implementation phase, very late as a matter of fact, to perform unit or component testing. This drives us to the conclusion we have mentioned earlier. Test automation in the waterfall model is more focused on the system level functionality. So I think this wraps up how automation is applied in the waterfall model. As you can see, a pretty straightforward old school development and testing process. But before moving to the next model, let's put all of this into perspective with a quick example. So imagine we are building a mobile app that converts units, say kilograms to pounds or centimeters to inches. Here's how test automation would look like in the waterfall model. So during the requirement phase, we document that the app should convert units with high precision. In the design phase, we create blueprints for the conversion logic, like the formulas that the app will be using. Now, when the implementation phase is complete, we finally get a working app. automation kicks in here. So we write test scripts to check system level functions, maybe something like, does the app correctly convert 1 kilogram to 2.2 pounds? Does the app round decimals properly? And does it handle edge cases like invalid input or empty fields? Very well. I'm sure you have noticed what's missing here. There is no automated testing of individual formulas during the implementation phase. That's because testing starts late, focusing only on the whole system. And there you have it. The waterfall model in all its methodical glory. It's predictable, structured, but let's be honest, not the snappiest approach, of course. Alright, folks, let's shift gears and talk about the V model. If you have ever seen this famous V shaped diagram, you'll know it's not just about testing. It's a whole philosophy on how development and testing are entangled. So, obviously, the V model is very structured. It's like a super oriented to do list. And for every development activity on the left side, like writing code or designing the system, there is a corresponding testing activity on the right side, like unit testing or system testing. So the process rushes sequentially, step by step, and that makes it pretty ideal for planning automation because, you can align your automation tasks with the development milestones. So at the bottom of the V, we start with low level requirements, which are essentially the code itself. Here, automation can step in early with unit testing. Climb up the V, this is where we meet the high level requirements, which describe how the entire system should behave and function. And at this stage, we automate system level tests to verify that all the pieces works together as intended. Now, here's where the V model gets really automation friendly. You can automate testing at any level, but only after its previous stage is complete. For example, you can't automate system tests until the individual components and their integration have been tested. This step by step approach gives your automation a clear roadmap with no guesswork involved. The last thing I want to tell you about the V model is that it's possible and even recommended to provide a test automation framework or TAF for each test level. TAF is a topic we're going to encounter later in this course, but for those who are curious, a test automation framework is like a toolkit, including the libraries, scripts, and processes needed to automate tests efficiently. So, in the V model, you might have one TAF for unit tests, another for integration tests, and a third one for system tests. It's recommended to have a TAF for each test level because it makes automation more organized and reusable. So instead of writing scripts for every test level, you're working smarter, not harder. Again, do not be overwhelmed by the term TAF. It's a very simple concept, but now it's not its time. Alright, everyone, let's talk about the superstar of software development methodologies, Agile. Agile is fast, flexible, and collaborative, and when it comes to test automation, it's like an open playground with endless possibilities. So let's dig into how test automation fits into Agile development line by line. So in Agile, software is built in small, manageable pieces called increments or iterations, meaning that we don't wait until all the pieces are ready. Instead, we test each piece as soon as it's done. For test automation, this means you can start early and happens in sync with the other development processes. Think of it as testing on the go. Now, here's one major advantage of Agile. There is always a runnable work product, I mean, a functional piece of software ready to be tested. This keeps test automation alive and active throughout the process. For example, if the team is just finished with the sign up feature, automation scripts can immediately test it while developers move on to the next feature, for instance, the login feature. This means automation in Agile happens continuously at all levels, from unit tests that validate individual functions to system level testing that ensures the app behaves as a whole. Even non functional testing, like performance or security testing, can be automated along the way. Hence, automation becomes a natural part of every activity, making the process faster and more reliable. Now, one of the coolest things about Agile is its flexibility. Basically, there are endless possibilities for designing a test automation solution or task, so you can create solutions tailored to the team's needs, the product's requirements, or even the skill set of the testers. So, want to integrate tasks with your CI CD pipelines? Go for it. Need tools for visual regression testing? Sure thing. The Agile Playground lets you experiment and innovate. And because of this endless diversity, test automation engineers or TAEs work closely with business representatives to plan automation efforts. They decide the roadmap and priorities, ensuring that automation aligns with the business goals, which eliminates the traditional us versus them mindset between testers and developers and help achieve goals faster. But it doesn't mean we cut corners in Agile. Some essential practices for successful automation must be integrated during Agile. For instance, code reviews to ensure high quality test scripts and static analysis to catch issues early in the code. So this saves time and effort down the road. Awesome. Let's wrap things up by looking at some common objectives of test automation in Agile. First, better coverage of all test levels with the appropriate amount of automation. You see, in Agile, we aim to automate what's most valuable, whether it's unit testing, integration testing, or system testing. I believe you get the point here. Second, eliminating silos between developers, TAEs, architects, and other stakeholders. So, Agile thrives on collaboration, and automating tasks are planned and executed together, breaking down barriers between the teams. And third, achieving in sprint test automation. Now, this is the gold standard in Agile. In sprint automation means that all automation tasks, such as writing test scripts, executing them, and updating frameworks, happen within the same sprint. So, no surprises and no waiting for the testing or validation phase. So, it keeps the team sprinting forward together. So, whether you're building a login feature or an entire app in Agile, automation is right there, keeping up with the pace of the development. All right, folks, we have officially survived the grand tour of test automation in different SDLC models. But before we wrap things up, we have to announce the Oscars for software development models, and the awards go to Best Drama goes to Waterfall Model, where automation shows up late and barely makes it to the stage. Best Supporting Role goes to the V model for pairing every development step with a corresponding test activity and keeping automation classy. And the Best Action Film goes to Agile for its non-stop, high-speed automation that doesn't skip a beat. Congratulations to all the winners, and for you, my friends, the award of MVP goes to you. So grab some coffee, and I'll see you on the next lecture, unless the waterfall delays me. Bye.